All right. Because you all wouldn't let me work on this before the start of stream, I got the bright idea in my head to start cleaning and documenting things. And then I lost my mic pack because I cleaned it away. Didn't find it until this countdown to the stream had already started. And I thought you guys would appreciate this because I was taking pictures of this stuff and there was a glare off of this piece of aluminum, and I put my battery for my microphone right there. There we go. So, all right. I used that to deflect the light to fix the reflection. So, okay, here we go. Today, we are continuing the Dasher Terminal recap and repair. We last left off after replacing almost all of the aluminum electrolytic capacitors in the CRT here, which is apparently...
Who says CHER 100 not on the floor? I'm disappointed with this off-brand location of on the desk. End of line.
Was that loud for everyone else? Also, Chloe, thank you for the 100 bits. Yeah, was that abnormally loud? That was... I don't know. Anyway, there is one other capacitor on this thing that I realized I did not change. It's a different brand, though, so I don't know if we need to. Okay, it was normal volume, good. Additionally, I don't know that I actually ordered a replacement. I was going to look through all of the parts here one more time. It would be a 1 microfarad, I think, radial capacitor. Oh, you know what? I probably just have that over here. I probably didn't order it because of that. 1 microfarad, 1 UF, 50 volt. Yeah, there's a bajillion of those. So let me see if I can show you this cap. It kind of sucks. Let's just see. It's really rough. So let's try and get way down in there. I'm just gonna plug this back in to get it out of the way here. Never mind. I'm just gonna hope that that doesn't get in the way. It's right there, blue one. All right. So first off, it has like the best negative marking I've ever seen. It's a circle with a negative and an arrow. That one's kind of sweet. It is really strangely marked, though.
CRAZYBOY 2025 SIs CHER 100. Do you have the bag ready to catch the magic smoke and push it back into the cap? End of line.
Crazy boy, thank you for the 100 bits. So yeah, you can see here, it's just marked.
Ryman says yet another sub thanks to being an Amazon Premier member. End of line.
You can see here, the capacitor is marked 1M16. And that's it. There are no other useful markings on it at all. So I'm assuming it's 1 microfarad, 16 volts. But I don't know if it's actually going to be that critical. So I think we might just try not replacing that one. We could try and remove it to see what it is. But I kind of want to try and leave it just because it's weird. So yeah, that's the one that was not replaced. Give me 1 second here because I don't have the information up for subs and stuff. Okay, so Philip is saying that it is slightly louder than normal for the deck talk. I'm gonna go turn it down. I think I bumped the volume on the deck talk. I don't remember it being this loud. All right, try that. I didn't have any other audio differences here. Okay. Trains in the Attic, thank you for the Prime sub and for 26 months there. What did I get on my finger? It's black. That's weird. That seems better.
Try that. Take that. End of line.
Chloe, thank you for the 100 bits. Okay. Do I have a schematic? I do not, but it might exist out there. Let me get a shot of this while I'm thinking about it.
CRAZYBOY 2025 SIZCHEER 100 Awoka your attention please, this is a sound test. End of line.
So that is the model and serial stuff for this CRT. It may be a Motorola, I'm not sure. So that information might be usable to find that stuff. But Philip here in chat absolutely has a weird word processor computer thing that has the exact same CRT in it. So it's this whole chassis, everything that's right here is identical. And Crazy Boy, thank you for the 100 bits. So I think we're ready to start the reassembly here. Which, gee, I'm so glad I get to do on a different day, because this thing is so easy to keep track of where parts are. Well, why don't I get my coffee within arm's reach? All right. Oh. Okay. This thing's a mess. Alrighty. Time to start the reassembly, I guess. I don't remember. I don't think I, did a, conclusion on this. Alright, that is all capacitors, except for one weird one that's a different brand and probably so I'm going to call that good enough. This pot here, though, I am told is the horizontal position. I might be leaving this open when I first run this so that I can attempt to adjust that, because the picture on this is pushed over to this side of the display to the point where it's actually kind of difficult to read the last character. So we're going to probably try to change that, and yeah, it looks like it's not going to be very fun. So we'll figure that out. But for right now, I need to get this thing rebuilt. All right, there we go. Maybe a mess, but at least it's not dirty and dusty. Oh, no, it definitely is. Here, there's a finger wipe of the bottom of the case. Is that a pot or a variable inductor? Pretty sure it's an inductor, so I'm probably going to take one of my wood cotton swabs, crack it in half, and use that jam down in there. Why is this thing gotta be so weird? Okay. I think we took the bottom off last. Although I think it really doesn't matter. I think we kind of both have to put the bottom and the side on at the same time. But I also have to get the individual loose cable. This thing sucks. Okay, hold on. Let me get that reference picture back up here. Google Photos, what are you doing? By the way, I measured one of the paper caps this morning that's out of circuit. It's a 1 microfarad cap. Don't worry about why the stupid LCR meter decided to show it as nanofarads. But it was like 2% off, which is like fantastic, and 2.8 ohms. 1/16 inch hex. Okay. That's, yeah, position. Okay. So the paper caps look fine, actually. All right, there we go. Those are the stupid wires that I need to keep track of. Let's have that at the ready over there. Just CRT inductor once with a metal tool, and it made the tool really hot. Huh. I have taken apart a surround AV receiver. It depends on how they're made. The Sony I disassembled had a bunch of those white connectors that are all keyed, so it wasn't a problem. Okay. Stripey goes, oh gosh, this is awful. You know what? Can we plug these in after the fact? No, I can't. Okay. Oh, man. This is rough. Oh, that's the connector, so that's got to be flipped all the way around. Okay. Yeah, Yeah, this goes here. Or wood, Poot, or wood. Come on. There we go. Okay, and then white one. And always the best wire color, purple. Okay. Oh, I don't like this. Okay. Well, Poot, we'll see. If the wood stick doesn't work, then I'm not doing it because I don't have anything else. So it's either it works or it doesn't. Oh, this is ugh. So last time I took this apart off camera before the stream, I disconnected way more cables, specifically around the deflection coils, and yeah, no ESD safe needed for this device. You are actually correct. There are no ICs on here. Well, there's a transistor right there. It doesn't matter. It's not an impedance right now. But okay. Wait, why are there two short ones and two long ones? Ruh-roh. I don't think it matters, though. Although maybe the short ones go into the plate that holds the TO2. Adjusting it does nothing at all. That's fun. Big dial at the back. I don't... Wait, you mean this thing? I don't know what else you might be talking about. Looks like big metal potentiometer with a white center. I don't know. I'm not sure mine has that. All right, now we attach sideboard. Really nervous about this rotating around so much. It's metal clips that poke out of that. And they could, in theory, scratch up the Aquadag or whatever it is, the metal coating in the inside, to the point where it doesn't connect anymore. Oh, that would be bad. So I'm trying to keep that in mind and prevent it from rotating, but it's, you know, not easy. Oh, this is going to be fun. Why are you not? There we go. Yeah, so this is an off-the-shelf CRT module, RemDog. So, in theory, it might actually be possible to replace this. Additionally, another thing I got out of some of the information that Philip shared with me yesterday is that I just put a long one there? No, well, that's weird. Why do I have two short ones? Yeah. Oh, because these hold the plates together. Now I'm confused. Oh well. It might be possible to replace this with a different generic CRT module because it's just horizontal vertical sync video, nothing fancy. So yeah, this really isn't that bespoke to the Data General. Oh, I was gonna not attach this actually because I still have to plug in the brightness pot and it's awful, but oh well. Yes, the recapping is all done yesterday. We just ran out of time to assemble and test it because it wasn't supposed to happen yesterday. How much brightness is lost to the cataract? So it doesn't actually have cataract, to be clear about that. So this CRT has some weird fading around the outside. Interestingly, Philips has the exact same thing going on. So it's not environmental. They just have ended up looking like that. But it is not, it's not really a problem. So I'm not sure. Once the display is on, you can't even tell that it's there. So, yeah. As much worse cataract, still perfectly bright? Yeah. But yeah, anyway. So yeah, it's not lifting yet, maybe. It's just like slightly discolored. I don't think that's a full-on CRT cataract. Maybe? But I don't know. Well, Sanity, I'm going to guess yes based on this weird implosion guard that seems to be holding another thing to this. If that's what that even is. That's the start of one. Okay. I wouldn't really know because I don't deal in old televisions. So. Not that I wouldn't. It's just, you know, I'm not going to pay $600 for someone's broken Predicta. Yeah. I stored for about 20 years, non-climate controlled area. Happens to start of it. Think the glue they used was a bit more stable. All right. So leave it alone for now. Oh yeah, I'm definitely not touching it. That's for sure. It seems fine. I'm not messing with it. All right, like I mentioned, I do still have to plug the brightness connector back in, but it is easier to install than it is to remove, so I'm not going to worry about that too much. Let me get the fuse. Yeah, weird board here screwed back in. Yeah, it does actually look a lot like the bad LCD glue. You got the white phosphor? Jealous? Really? Because that's probably the easiest part to change. I mean, as long as you get a tube. Although, this is kind of an early tube. Maybe it's not as easy to get a replacement for. Yeah, I saw yours is green. I wouldn't trade because the dasher is always white. But if it was anything else, I prefer green. Really weird flat bell. Yeah, I was thinking it is kind of short. Kind of impressive, actually. So Swarm of Dead Insects, it is not impossible to make a new CRT. If you look at the Applied Science YouTube channel, he was testing a method of drawing a vacuum using some kind of weird like humidifier thing that is supposed to get like super ultra pure vacuums, and was able to just like dump some phosphor in the bottom of an Erlenmeyer flask and get it to function as a rudimentary bad CRT. So it is kind of possible. Yeah, I think that's where that went. Let me recheck photos. Unfortunately, I didn't take a picture of that one, so I'm going to have to go back to January. Did I not take a photo of that at all? Oh, cool. I'm smart. Okay. Well, can't really go anywhere else. Okay. Made it finally. How broken is this? On scale business as usual. Well, we haven't really started. Wait, that just moves? I don't think there was ever a screw there.
Sleepy developer subbed as tier 1 and says, end of line.
Huh. Sleepy developer, thank you for the tier 1 sub and for 4 months. I think I'm gonna put this there because that just doesn't seem right. Yes, the 3 loose wires were reconnected. They are impossible for you to see here, so you're just gonna have to take my word for it. All right. I think we just plunk it back in. Yeah, business as usual. We haven't got to the test fire yet. Oh, you know, dang it. I was gonna once over check the polarities on everything. Yeah, I'd really rather not mess with the look of the dasher too much if I can avoid it. Okay, I think everything is good. Okay. We can just drop the CRT back in. There's no reason to bolt it back in yet. We're going to do that. All right, the CRT chassis is back together now, so I'm going to go ahead and plop it back in here. I'm not going to tighten it down yet, in case something doesn't go right. And then we'll test it. I'll also leave it somewhat open for me to try and get to the horizontal position adjustment so that I can try and fix the character positioning. Okay, let's brighten this thing real hard to get in there. Let's see if I can make this work. Yep, that's pretty terrible. Got it. double check that. Yep, looks good. Moment, let me reorder. Oh, that's not fun to remove. Okay. I think that's it. Technically, did not reconnect this ground strap, so I'm just going to kind of jam it in there for now. I will fix that before I redo the entire thing. Power here, just a handful of little things to check. Okay, I'm going to put this board back in place. And I think we're ready to try it. I'm going to grab my flashlight and look through there because there's a lot of weird little connectors I could have disconnected. I would like to just make sure everything's looking good. All right, I think that's it. Let me grab a power cable. Oh, there's the beeper. Oh, it's pointed at the back so everyone else can hear it. That's smart. It's not powered. Ah, okay. That's what I wanted to check. Make sure that was pushed in. Okay. Adjustment knob just fell off of my ball head. Strangely, it's the exact same adjustment knob that I lost on my other one. Okay. All right. That is power plugged in there. Power is going to it. Let's turn it on. Now the brightness is at about halfway. We should see blinking cursor up here. Well, it's not at about halfway. I just did a little turn on it. Blinking cursor. And it did the exact same thing. The problem didn't go away. What? Here's power again. Brightness is low. It'll probably work. Or not. No. Well, yeah, why is it? So when I turn the brightness up, it collapses the field. That doesn't make sense. Yeah, checking voltages is annoying, but I can. Here's the thing that really bothers me. Let me see if I can bring this up on stream. It may be power supply related.
100 subbed as tier 1 and says end of line.
John Lego, thank you for the tier 1 sub and for 3 months. I appreciate that. Come on. Where's Blinky Cursor? Okay. Play. Come on. Where is it? Blink. Okay. And there. Oh, that's not what I thought it was. So I thought that was underscore characters being printed to the display. It's non-linear though, so it's not that. Or maybe not. Well, the timeline's messing with me on the camera. Okay, I want it to barely go ahead. I can't make it out on here. I swear it's underscores. Yeah, it might be retrace. Yeah. Could it be the paper caps? The Dasher's always done this, Ramdog Cap. I wish it was possible to test it outside of this thing. And without the origami of how all the boards go in there. It's so awful. Kind of really surprised that it's not the do one UF cap in it. I don't even want to entertain that, not because it couldn't be that, but because that is a lot of work to do to replace the one part. It is a lot. At least I think it is. Let me see. I don't like doing that because it puts a lot of weight on the plastic. But on the other hand, the plastic is crazy thick. Okay. Why does the AC smell so weird? You know what? I have pictures of that. Let me see if I can figure out what the ref is. I can get to the back of the cap. I can't reinstall it correctly, though. So I might be able to remove it here and then bodge the back. But that's as good as it's going to get without completely dismantling the thing. Let me check my reference photos. See if I can find the ref des for that one so I know which one to remove. It is C52, excuse me. Unlike all of the Data General PCBs, these Motorola ones are really nice, and they have ref designators on the fronts and backs of the boards. So I can just look right in here for it and figure out which one it is. Well, yeah, I could install it on the back, but I'm not doing that in the long run. Polarity is going to be fun, too. I guess my image of that may indicate it. If I can figure out the orientation completely. All right, C52. There was one more capacitor in here that I didn't replace, that little blue electrolytic one. I could attempt to replace that here, and I think I can get to it from the back side. I'm trying to see if I can find it here. It may be not, it's difficult, but I think this is it right there. So I might be able to pull it out and then put a new one on the backside to test here really quick. I concur, it is negative to the bottom. And now we wait. Because the desoldering iron's heating up. While I'm doing that, let me just go grab a new cap for it. Let's see, we got the 50 volt 1 UF. There's a 160 volt 1 UF. I guess I'm gonna go 50. All right. 1 volt, 50 microfarad. Okay. Not 1 volt, 1 microfarad, 50 volts. It is a radial cap, and that's what I grabbed. Okay. See if this is heated up. Man, desoldering iron always takes so long to heat up. Thermal mass, though, it's hard to argue. All right, it's ready. Okay. That is a loose trace. Cool. This leg is bent over on the cap, which kind of sucks. Oh my gosh, I managed to unbend it. That's a miracle. Okay. Where are you? Of course, there's everything in the way to get to it. All right. All right, it is loose. Now I just need to extract it. I'm not convinced that's the other leg of C52.
Snowboard Monkey subbed as Prime and says, end of line.
Snowboard Monkey, thank you for the Prime sub and for 6 months. I appreciate that. I think it's farther down. That's it. Okay, I'm not going to be able to hit that one with the desoldering iron, though. I do have a solder sucker, but there's a piece of metal right there. Additionally, I have a full desoldering iron that's way, way better than a solder sucker. But again, there's steel in the way. All right, come on. So it's approaching. More difficult to do it this way than it would have been to dismantle this. I don't like that. Lost grip. Come on. Oh, it's so hard to see. I should be able to persuade it out. It's just Really messing with me. You know what? We're going to try the desoldering iron at a weird angle. See if I can just make it work. That did it. Okay. Now I can press it out. And can I grab it? Okay, well, it's definitely loose. Now I just need it to not be loose inside of here. Ha ha! Well, I'm going to let the open cap surgery, let you speculate there, Machenko. Black Simon and viewers, hello and welcome. We are currently diagnosing an issue with my Data General Dasher terminal here. I just removed C52 from the CRT's analog board, and I'm about to check it with an LCR meter so that we can see what's up with it. We just removed all of the other aluminum electrolytic capacitors and replaced those, and it didn't fix a weird issue that it has where if I adjust the brightness up too much, it'll shut off, and then it won't show video again until it is like cooled overnight. So trying to diagnose that issue. And now let's see what the results are on this capacitor. So let's go here, ESR. 16 ohms ESR, huh? That seems a little not optimal. Huh. Okay, well, we may have found the cause of this problem. At what frequency? That's 1 kilohertz. If we drop it to 100 hertz, 79 ohms ESR? Okay, those are stupid numbers. Dude, if it's this one, that's amazing. All right, well, that thing's yoinked. Is that the one you didn't replace? Yeah, why would I replace the bad one? Duh. Okay, so negative goes towards the bottom, positive goes towards the top. This is going to be a little weird. I'll form the leads in a particular way here. Try and get this to work well. Oh, this is not going to be very clean. Poot, you'd called out any other capacitor being it before the stream had even started. You don't get credit for that. I don't think it has, let's see, does it have any branding? It is, yeah, Sanyo. And now it's Ganyo. No, it's just over there. Okay. Let me double check. Yep, negative to the bottom. Let's put power to the iron, actually. ready. I gotta be careful with this one because the pad trace has lifted. Okay. That's clear of everything around it. Okay. I think we're ready to set it down and try it again. Slides with tape into the legs so they can't touch anything. They're not going to touch anything for the one test power I'm about to do, and then I am going to tear it apart and put it on correctly if that's the case. Notorious for failing if it's one of those? Oh, well, then we potentially found the problem. Okay, that's in there. I didn't disconnect anything else to do that test. So, all right, we're ready to just fire it up again. All right, time for test 2 here. We've replaced C52, which is a Sanyo cap that I'm being told is infamous for being bad. I already have power pulled out here, so I'm going to hit the switch on the power strip over here and see what happens. I hear raster. And that's a fail. So that was not it. There is still more wrong with it. I don't think it's going to be the power switch, but just in case, that's pulled out. It's minimum brightness, raster. Well, I hear high voltage. How about that? Man, that's a weird one. But Philip, it shouldn't be the black level pot. With the raster collapsing and then it doesn't come back, it shouldn't be that. I don't know what increasing brightness, overload, shutting down power supply. I don't, it's hard to say. So here's the thing. This has composite video out. And that works fine. So I don't know. I do have one idea. Let me unplug power here. Just cycle that. There's one data general board on this that is power related. And it has some of those little axial caps. I did not think to get replacements for those. I completely failed to notice those, actually. I wonder. Yeah, Helen Croft, that's what I'm thinking. $20 microfarad, 0.04 ESR, that seems probably right. $20 mic, 0.2. $260, 0.04. Oh, I measured that one backwards, maybe. Actually, it's hard to tell which way they should be. Okay, see the plus there, plus there. Okay, I did measure that one backwards. I'm sorry, Mr. Capacitor. Why is that one backwards from all the other ones? $260, 0.4. Okay, that seems a little weird. It should be 22 UF. Okay, I say we lift that one. Do a different test. Or do the test again with it lifted. It would be easy to resolder on this side, so I'm doing that. Unfortunately, Data General doesn't believe in ground planes, so this is going to suck. Or they don't believe in sprocketing. I have no idea how I'm going to do this. Maybe we just lift the other side. Where it'll be easier. Yeah, it works when it's cool. That part is really strange. Why is this not lifting? What? Is it bent over on the bottom or something stupid like that? Jeez. Well, we pulled these out and reformed them. They're good. They're not even warm. So I'm pretty sure they're not going to be dead short. Yeah, everything's too dense to try and do IR cam. That's not going to be the answer here. Yep, leg is super folded over. Thanks, Data General. Oh, sure, they sprocketed the leg on this side. Oh my gosh, that's brutal. I'm not necessarily going to replace it. In-circuit measurements are not valid. That might be enough to pull it out from the top. There we go. Jeez. Okay. Positive is far side. Wait a minute. Two. Dude, I hate the tweezers. 239 nanofarads? 31 ohms? That would be garbage. Okay, it's not dead short. Am I going to have to remove these stupid TO2s? I really don't want. Oh, I can't even. I would have to desolder them. Ugh. Dude, these might really suck to replace. And I don't even think this is going to be it. What capacitance is it supposed to have? It's listed, it's rated at 22 microfarad on it. Let me get the better clips on here, maybe. I don't really like the tweezers. $240 nanofarad. It's off of 70 volts DC. Huh. That would be this right there. Goes directly to transformer. And then I have this board, which I don't think yours had. You have a transformer down in there for some reason. It's clearly not going to be doing its job, but it's so far upstream. I mean, maybe that just so happens to be the bad rail, I guess. I also just really don't want it to be that, because that sucks to try and remove. Like, really bad. And I don't know if I have that. Okay, let me look at my cap catalog. Yeah, 20 DC, 22 microfarad. $22 160. 2216. I marked it as LI. I don't remember what that means. Low inductance. 22 100. Why are they enormous? It's a shame I don't have a 22, like 35 volt or something. That would be nice.
Rich Files subbed as tier 1 and says I like big caps and I cannot lie. End of line.
Rich Files, thank you for the tier 1 sub and for 3 months. Was that rail 4 even? I don't know. It was one of the like 3 main rails or something. I don't know. Seems like it's important or whatever. I mean, it goes to this TO2, which is an LM323K. Like, this is the smallest 22 microfarad cap I've got. And it's going to be a nightmare to put in there. I don't like these paper caps here either, but yeah, now. Yeah, oh, I hadn't even considered about the axial versus radial. That's a whole other issue. All right, let's try and cram this in there and see what happens. So, positive side. So, just for my own sanity here, positive towards the U1, right? At first I thought that was a hipster 5. But no, positive towards U1 on the thick rail. That's going to be a complete nightmare to try and solder to. That looks like a plus mark. I think it might be 0.22 because that would be correct. Oh my gosh, it's 0.22. So it's fine. Why are there not leading zeros on everything? Ugh. Dude, trying to get that back in there, man. Ugh. Yeah, I'm glad that we caught that. Disappointed we wasted that time on it. Getting increasingly disappointed that we're running out of suspects here. It's only a sample set of 1, but while I'm waiting for the thing to heat up, this was one of the paper caps this morning. It was a 1 microfarad paper cap measuring at 1000 nanofarad, which is correct, and 2.8 ohms ESR. So the paper caps might be fine. It's hard to say. I'm gonna go put the not getting used capacitor back. The yellow one should be okay. All right. The problem with the CRT is weird. It's complicated. I need that leg to be flat. There we go. Okay. Now I just got to flood that with solder. Okay. So it's probably not this board. We can safely ignore that. Ugh. Hmm. Okay. That seems important. I wonder when that happened. Hmm. So this wire was loose like the whole time. Trying to figure out when exactly it may have come loose. And where it was originally. So one moment. Still one moment. Oh my gosh. Why? What? Okay. So this is a photo I took this morning. One moment. Let's just do it this way. Way down in here. Touchscreen. Why? I think this is Gwenview sucking yet again. That doesn't look like it's in the correct place. That's the worst brightness ever. And the worst contrast. Cool. Thanks, Gwenview, for being Gwenview. So it wasn't there then. Okay. It is time for deeper investigations here. I need to know this. I need to know where that went. I need to know when it came loose. So we have some investigations that we need to do. Because that is significant, potentially. Okay. It's not going to be a line voltage switch wire. There's only one place it can go. I know where it goes. But when did it fall off? I don't know why YouTube shows you ads on your own channel. They force you to violate the rules. Okay. Does the wire look like it's in place there? I don't think it is. So we're going to get farther in there when we get to the caps. What can we see, though? Pretty sure that blue wire is loose. Yeah, that's loose there. Okay. So it was loose during the Usagi stream. It was loose when it was still working, but it wasn't working great the whole time. This is a photo I took while picking the capacitors. That might, no, that's going to that pink connector. It's really hard to tell if it's connected there. That was like the only one that it was actually even close to visible in, unfortunately. Well, this too. Yeah, it's not possible to tell. Just trying to look through all the photos, see if there's anything that can indicate. There's this one. And maybe it's in the right spot there. And that's basically it. Okay, so there's one more thing I can check. And I have to go to my server for that. How many places can it connect to? One. Okay, this is my server. These are my original recordings from 5 years ago when I first dismantled the Dasher. So let's see what we can find in this, if anything. These are B-RAW files, so I can't easily play them anywhere but the server right now. It was only 600 megs, that's nothing. Okay. Yeah, it was super dirty when I first got it. I think this one's going to be more air cleaning. Yeah. 7.7. Okay, so this is long enough to bring it back in. Nope, still out there getting air cleaned. It was a dirty terminal. Back in here. Okay, do I get the back down? I do. Okay, can't see the wire. 15 gigs. I mean, if anything's going to show it, okay. Come on. Yeah, this is when I marked it. We don't have any schematics for this. I mean, it's really hard to tell, partly because this is that one's 20 gigs. Okay, here's what we're going to do. One moment. Let me just double check something. All right. Server might lag a little bit. I'm opening DaVinci Resolve on my server so I can add some color correction to this. And zoom it in. We might be able to see when the caps are removed. You're correct. Okay, so it was 13 and 14. Just go through here. Okay, color. That was not ATEM firmware. Ooh, yeah, it might be visible over there. Okay. On. Make the timeline 4K because it won't give us full resolution of the image if it's not. All right, here we go. Inconclusive. Okay, I think that is connected right there to where it should be. Yeah. Okay. So it may have happened when I took it apart to document all the caps to order for Usagi. Because that really looks like it's going to the front pin. It's real hard to tell. It's a Dasher D2 or a 6053. That was through 16. The rest of this just... it's all useless. It's a shame this wasn't angled slightly higher up without the caps in there. All right. Okay. You do have schematics for the 6053. Oh, that's right. They're the wonky ones. Okay, fine. Yeah, they exist. Actually, do I just have them on here already? I might. Been trying to have this computer Nextcloud sync everything. Okay. Power. Yeah, you sure it's there? Terminal power supply. Power supply. Okay. It might be 7 blue. So I mean, I can see why I didn't get a good shot of it. It's really hard to get a good shot of it. It goes to A on here. Man, this sucks. Right there. That's the one good angle. So it goes right here. So what is A on that? Yeah, there's no way it's like a loss of 5-volt rail. So it's a loss of half the juice behind the 5-volt rail. Ooh, okay. It's this. It goes here. So that's 4 on the transformer. Wouldn't a voltage selector be literally no power getting through, though? Also, this is unfortunate. I just noticed 2 more places where it could theoretically go. There are 2 more pins in there. Yeah, it's not really making a whole lot of sense, Hollyhops. This is why I wanted to trace down when it theoretically happened. Matter of fact, let's go review yesterday's stream. We have the image where it's still connected. It's really difficult to see. I'm going to go look at yesterday's stream. See if when we cracked it open, if we can see that. Again, with the ads on your own channel. Okay, that seems pretty clearly not connected. It's floating way out there. Do I ever bring the camera over it? That's less convincing. It actually kind of seems in line. I don't think we go back to the chassis for the rest of the stream. No. It's really hard to tell. Because it's entirely possible that got lifted when I unplugged this connector. Just the position memory of the wire, maybe. Yeah, because that seems too far over. Man. Zooming in isn't going to help. It's a 1080p stream, it's a 1080p monitor. There's no more pixels to look at. There ain't squat visible in the original photos. That's resting on top of that wire, for sure. Okay, so what Ben is saying there makes sense. Because it being for line selection doesn't make sense if it doesn't do anything. So just coincidentally, at some point, I managed to knock loose a wire that was just going to a dummy pin. Also, I love how Data General uses whatever their own part numbers are for what these capacitors do. Just, you could have written the microfarads there, but no, you wrote your own part number that translates on some table we don't have. Thanks. Okay.
Dr. Stoffel says CHER 100 and non-standard documentation for non-standard terminal for non-standard computer ... This is non-standard exception ... End of line.
Dr. Stoffel, thank you for the 100 bits, and yeah. So here's why I wasn't really paying too much about voltage selection. That's actually done with this little switchboard thing. You pull this out, flip it over, and then put it back in for 220. I don't get what the taps here realistically do, but maybe the blue one really doesn't matter. But that wire isn't supposed to be loose. It has somewhere to go. That just seemed like a really good thing to investigate to potentially discover what the issue is here, but it is not. Okay. I think we take off the only remaining electrolytic, which is that one, the dual element. I don't know, I mean test voltage at the board. I mean, I know obviously like probe, but we got weird stuff going on here. Also, pretty sure none of my meters can measure anything like even close to CRT voltages, so it's not like I can actually measure that stuff. One thing I could do is check these connectors for strain, because I have taken this out a couple of times and they're in there in a really awful position. I might have damaged them. Small back red wire, 60 VDC on that. Or 70 VDC, okay. I can read. So that comes from... Oh, you're saying it would come from this. Okay. Interesting. Oh, I guess we can check it. Let me just look at the connector solder joints. They all got the weird rivet things in there, so they look strange. All right, I'll reattach it just so that it's not going to loosen and short anything, and then we'll turn it back on and see what we get. Love how I set up the GPIB stuff and then just keep using the fluke. Because this is too big to take over to the workbench. Okay. All right, everything should be good. Gotta be honest, I'm not super thrilled about the idea of having my face pointed right at this right now. Maybe I don't have that jammed in there enough. Holy moly, that has to go way in there. Saying that should be 70 DC. So it shouldn't be. Oh, there we go. Of course. First time I measured it, it was 0. I want to check. There is no cursor. Ah! That failed when the raster collapsed. All right, power. Raster just collapsed. Yeah, that's dropping. There's something wrong on that board. We're changing the dual element cap. Actually, I need to record this. We have our smoking GNU. I think we have a smoking BSD, maybe. Okay. I found something, thanks to the help of Philip here, who actually has one of these CRTs in a weird word processor thing from around the same time. It's the exact same chassis. So we're turning it on here. This is the power supply that is internally regulated within the CRT cage for 70 volts. As I turn up the brightness, we'll see eventually the raster will collapse, but also pay attention to the voltage on the multimeter. Ooh. Yeah, that's what I was talking about. That's in line. I don't think that's retrace. That was new. We haven't actually recorded that. Okay. That's what I was thinking is possibly the character generation being wrong. Well, the multimeter didn't change anyway, so... I want composite output at the same time. No, Old Master, it's just behaving weird. Also not sure if the video capture is working correctly now. or if it's just like dead. Okay, blinking cursor on video capture this time. I'm going to turn up the brightness. I would love it if we got the lines again, but I don't know if we're going to. I'm going to try and go really instantly, no voltage, and then it reset all on its own. Okay. And of course the video capture covered everyone. Okay, trying one more time. The video capture's boned. I'm going to try power cycling it. Okay, I'm going to go power cycle. This thing's driving me crazy. Oh, yeah, I need to stop recording here now because that killed that. Is this B plus what we're measuring here? Why am I not getting signal? Well, I'm going to slowly turn this up again. Nope. All right. I give up on that. We're clearly getting voltage loss on probably higher current consumption, though. To exactly 70. I'm pulling the cap and checking it. I don't care. I don't know where B plus is. Apparently they have found some schematic for this thing. I don't have it. Anyway, this is the cap that it wants me to change or adjust, and that's going to suck to do while it's in there. let me more directly ask this. Do you all have a service guide or schematic or manual or something for this CRT chassis? Oh, so there is a hole in the top. Well, that makes more sense. Okay. Yes. Can you link it in chat? Okay. Let me go grab that. Okay. It's in the terminal guide. In that case, yeah, I do have it. Okay. Why did the touchscreen just stop working? That was weird. Okay. There we go. All right. I'm not going to any particular page. I'm just reading the thing. All right. So mine is an M3000. Okay. All right. This is weird. Never seen this before. 1000 ohm volt or higher AC voltmeter. 10 watt resistor, insulator. Is this for like really high voltage measurement? That's weird. Okay. Let's look through this. Composite video input. Okay. But it's not. Okay. TTL horizontal and vertical sync pulses. Yep. 70 volts DC is required to regulate the power supply for both models. Universal power transformer permits operating the monitor either 115 or 230. Output connections monitor made through 10-inch card connector. I'm just reading through this. Input, or hold on. Put in output connections for the monitor made through the 10-pin card edge connector on the vertical video circuit card. Inputs consist of video, horizontal, vertical sync, signal ground. One additional input optional TTL level step scan may be connected to the monitor via 10-inch connector. Output connections are provided for an optional remote brightness control. We have that. Circuitry consists of 2 stages for video amplification, 5 stages, vertical sync, deflection, processing, 5 stages for horizontal sync, regulated 70 volt power supply. Models also have available dynamic focusing, vertical blinking, amplifier, horizontal sync step scan. No, they're not using composite input. I don't know why they're calling it that. 4 etch circuit cards used, handling all the stuff. An optional low voltage logic power supply is available when remote power source is required for logic circuitry. Components are mounted on top circuit cards. Foil. Schematic numbers are printed on top and bottom of each circuit card. Yep, that one, that's like the best feature of this thing. Okay. Circuit tracing component. Base collector. Yeah. Moving components from an edge circuit board is facilitated by the fact that the circuitry copper foil appears on one side of the circuitry and only component leads are inserted straight through the holes, not bent or crimped. They didn't quite get that. It's recommended that solder extracting gun be used to aid in component removal. That's kind of hilarious. Iron temperature controlled heating element would be desirable since reduce possibility of damaging circuitry. Well, I mean, don't tell me what temperature to use or anything like that. You know, just have it be temperature controllable. Just having that will make it, work great. Nozzle soldering extracting guns insert directly over the component lead. Yep. Placing plug-in transistors, please observe the following precaution. Transistor sockets are not captive, which means transistor mounting screws. Okay. So there might be Weird stuff. Transistor mounting screws. Yeah. CRT replacement. We're not doing that. Okay. Regulator adjustment. Okay. Connect the monitor AC line supply. Apply test signal to proper input. Signal should be same amplitude and sync rates. So when monitor is in service, adjust horizontal set coil L15 horizontal till display is stable. Connect DC digital voltmeter or equivalent precision voltmeter to the emitter of the regular output Q transistor or any 70 volt test point on the power supply circuit. Adjust 70 volt, adjust R15 on the power supply circuit. Output of 70 volts. Do not rotate the control through its entire range. Diameter may result. When adjustment is complete, AC lines check 130. Check for project regulation. Horizontal hold. Okay, yes. So it definitely wants that. Horizontal coil L50. Horizontal blanking lines. Dynamic focus. Factory set should not normally require further adjustment. You're not worried about focus currently. Okay. That's still focus? Yeah, okay. So, why are these arrows like bidirectional? That's so weird. Horizontal sync delay. Oh, that's weird. AC regulated power supply 70. Yeah, so that's completely separate. So it's just straight past line voltage. Okay. And then an output 70. Why are there more controls? Oh, there's a externally mounted transistor. Okay, that's what that is. So there's AC externally mounted transistor, and then adjustment I mark, question mark in the picture, horizontal linearity. I have never heard of a horizontal linearity adjustment. That's weird. Okay. 7 volts, appears emitter, Q150. Place the line voltage input with winding off their own transformer, but that's fine. Yeah. I'm thinking that's just a 1-to-1 section. Do we still have that open? To low voltage AC to monitor. Low voltage AC. Well, don't tell me what the low voltage is, you know. Okay. Probably matches Motorola's secondary winding output. Maybe. 70 out, signal ground. Okay. Wow, okay. Am I understanding this right? That the regulator for the final adjustment is literally a voltage divider using the potentiometer? Establishes fixed reference, increase in voltage output, increase components. Said so earlier, I mean, it said voltage divider. Is divided between, yeah, that's, are you sure it's a feedback circuit controlled by the op amp? Because I think it's a voltage divider. Which explains why one of the resistors in there looks a little toasty. All right then. It is feeding back. Increase in voltage output will result in an increase of voltage across space of, with conducting glass, the output voltage will be lowered. No. I have a really hard time believing that the 2-volt increase is going to be the problem. But we'll check that. I think we might have 2 problems, actually. I think our video amplifier is bad, and then maybe this power supply is bad. Do they not have a theory of operation for the video amplifier? Vertical output, sync shaper, vertical driver, vertical oscillator, horizontal, dynamic focus, horizontal, phase, sync delay, horizontal sync delay. Video amplifier, here we go. So just Q100, 101 are connected to cascade, configuration. Okay. Video amplifier circuit, okay. Okay, so we changed which capacitors in this? None. None of the capacitors we changed are in the video amplifier. I'm saying C106 we didn't change, but it's electrolytic? I didn't see it. Okay, none of those are there. That one also not there. That one not there. That one not there. I wonder... These are all the weird small paper caps. Because I didn't check any of those. All right, let me read through this entire thing. Then we'll go adjust the 70 down to whatever, the 72 down to 170, and then we're going to look through this a little more closely. Four volts peak to peak, DC coupled to the base of Q100 via R100. R112 provides proper termination for the high frequency video input. Okay. During no signal conditions, Q100 is off. There is always a signal. Q101, however, is forward biased by 6.2 volts on its base, which is established by a Zener diode. When a video signal is applied to the base of Q100, it conducts, causes forward bias in Q101. Result on output is developed across 104, collector, DC coupled, peaking coil, resistors, CRT, arcing, capacitor, shunt surround. Okay, really not a lot going on there. Yeah, so unless one of these capacitors are shorted to ground, I don't think they're doing a lot. Yeah, I'm thinking I'm going to scope the video path. Not sure you mean the monitor has no protection circuit. I don't see a C106 here either. Yeah, I know. Check the Zener diode, yes. The raster is fine. It is always rastering. We have a brightness issue with likely the video amplifier. That kills the high HV if it goes too high. No, I don't have a replacement board for a 1975 video monitor, no. I wonder what year this might say. 77 for this. But the terminal was designed in 75. It shuts down, but that could be too much current draw on the power supply, causing the feedback to collapse. So yeah, what might be happening is too much current draw over this, and then this just like, it's not able to keep up the loop. Old Master, what would B plus be to you in what you have seen of these schematics? Would it be the 70 volts? Because I'm not sure what you're thinking it is on this. So you're saying the 70 volt is a B plus. Oh, that's hilarious. That's what step scan is. That's amazing. Okay. That's super cool. Yeah, I appreciate that, Helen Croft. Vertical video circuit. There's a complete schematic. Okay. Trying to look through this to see. Okay, so this is the video amplifier section up here. Okay. We're trying to visualize this. So it's going to be the bottom one. So this is the bottom. Why doesn't this have brightness on it then? What? Horizontal. Why does the horizontal have the brightness? The fuse solder pad that sticks out. AC, okay. You're wanting to see what the voltage going in is shown in the full schematic. All right. Oh, man, look at that thing. Okay. Master bright. Brightness. Okay, so there. Okay. But again, that's on. Yeah, so that has C106. Yeah, I think we need to find C106 for sure and look at that. Because if that's failed short, yeah, that seems like it would cause problems. I think that's showing a ground connection right there, maybe. No, because that's the earth ground. Where? So there's. That has to be what? Hold on. So we have one side of the tap. It can't just go to a resistor and capacitor. It's got to go to something else. Oh, it goes to minus 70. What? Where's minus 70 coming from? All right, let's go adjust the 70 volt. I'll check probe chassis, diffuse solder pad on PSU board, 6 out, 4 and after raster collapse. So bell? You mean this one? So probe this? It barely sticks out, but okay. You know what? Before I seal that away, that is an Allen. Let me see if I can find a properly sized Allen wrench for this. It's going to be a little bit of a tall order here. Or I'm going to immediately find the perfect one. Yeah, we'll clip to the chassis on one side, and then we'll do the probe on the other. Yeah, you're saying the brightness dial, so I'm going to not adjust the 72 volts first. Well, the regulator on this is externally mounted down below, so it's kind of a pain in the butt to get to and look at. I would actually have to remove the CRT in order to see it, so we're not going to see that today. Fully insulated nose probe recommended. Yeah, that does look a little spooky down there. I do have that. Okay. I hear raster. $40 VAC. That seems a little low if it's supposed to be 45. I don't like this. It is very difficult for me to hold that. I need to move the camera. This ain't gonna fly. Back. Badoom. Okay. I have blinking cursor. And I think I just maxed out brightness. That's maxed out brightness. I hate this thing. Okay, let me switch gears and look at the voltage. Yeah, we might clean the fuse in a second, I guess. But let me adjust the voltage. Let's not have it set to AC. It is glued. I'm not touching it. To give you an idea, I got it to go down to like 71 by just barely moving it at all. Like I was just twisting it like that much. Yeah, we're not touching that. Okay, stupid monitor. Why are you working? Yeah, we're now going to reflow every single solder joint on the fuse board to a connector. And we'll deox it and rotate the fuse. Do I have a fuse rotator? Right there. Comes pre-installed. Terminal and floppy drive? I don't know. I don't know, man. At least they're not copper fuse holders. They're brass. They weren't complete idiots. Because the fuses are typically aluminum and copper, aluminum. They aren't friends for long. Should be a 1 amp slow blow. There's a sticker on there that says that, yeah. Let's see what it actually is. So 1 amp. Like I said, every connector is getting reflowed. Oh, they're hot. Actually, I kind of don't like the look of this one. So maybe a thing there. Who knows? Sure, let's reflow the fuse connector too. Why not? One nearest to your fingers looks janky. This, yeah, so there's a pin that's cut so that there's only the two for the AC input. And then those two are bridged. I didn't design it. Yeah, there's the glue on that, by the way. Why I'm not... No, you can't see squat because I'm so zoomed out. Just looks like trash from the factory things, but Motorola, yeah. Yeah, there's the glue on the potentiometer that prevents me from being able to adjust that. Let's just do... Actually, let's do this fancy, like... where'd it go? There we go. Wire brush with deoxit. There's no testing the big dual cap in circuit. Yeah. Why I kept saying I'm going to remove it. But I didn't trust it for squat. Okay. Give that a try again, I guess, or... Cartos, I don't want to talk about it. It worked, and I don't know why. I'm getting tired of that being the case.
Coon says CHER 100 who knew data general equipment came with the Troubleshooting setting set to on. End of line.
Yeah, no kidding. And Chloe, thank you for the 100 bits. Okay. Digital Ice Age, some days that's what it feels like. Okay. So we're going to check on the fuse and, you know, some stuff. I don't know. Free me from this nightmare. Okay. I'm going to give it a second. Ah, vertical collapse, or collapse. 2 volt AC. Whoa. Hell. What? Repower 40. Oh, we're back to that. That's blinking characters.
CRAZYBOY 2025
That's digital acting weird.
CHER 100 just remember with data general all your problems go away : D. End of line.
Oh, that's so messed up. What on earth? The rest of the chassis does have a fuse. Why were you suspecting that test point?
Belgiumet says all aboard the CRT repair hype train. Choo choo. T.tickets please.no not gyro tickets art what have I done CHER 100. End of line.
Majego, thank you for the 100 bits. I put deoxit on the fuse. I just got a notification, apparently, that someone's at my house. Okay. And I've cycled the fuse a couple of times. Because high resistance connection usually spike in resistance upon the high current draw. All right. Okay, it's on. I hear raster. I'm not having a good time today. What do you mean, check it? I already pulled it out and cycled it. You want me to just like literally resistance measurement check it, or replug voltage selection pins? That feels like a reasonable idea. Of course, sacrificing a chicken at this point feels like a reasonable idea, so. That is what this is. That is that fuse.
JEPIN 247S.ISU look bump dot dot here's a little cheer dot CHER 1000 end of line.
Cheapin, thank you for the 1,000 bits. I really appreciate that. I am a little bummed. Because this is a really weird problem. Yeah, so that's the rear case fuse.
My disappointment is immeasurable and my day is ruined. End of line.
Kinda. Oh, thank you for the 33 months of tier 1 sub. I really appreciate that. No, it's 35. 35 months of tier 1 sub. Thank you.
CRAZYBOY 2025 SICHER 100 asking the question out loud. Why are we repeatedly checking the fuse? End of line.
Crazy Boy, thank you for the 100 bits. Because the connection can be weird. The problem has happened on other power strips than this. Philip, it's not that. I'm going to wiggle all of the voltage select lines. Okay, I'm going to unplug and replug all of the voltage select cables. Additionally, that power strip is what I've been running the entire Nova and disk drive stack off of. For those of you playing along at home, it cannot be capacitors right now with a voltage sag on the AC. There are, as far as I know, are no AC capacitors in this. Maybe these two weird paper ones. Nope, those are DC. There are no AC caps in here. Oh, that one kind of sucked. Okay, I have reseated all of the voltage selection wires. It's P3, janky from factory pins. First good stop after that, concur. And out transformers, good suspect, yeah. So, for the record here, let me show the fuse holder. So I'm just gonna pop this back in now. I've already deoxed it. Well, there it is. I'm gonna guess they do, Philip. Because that would explain why we get garbage on the screen. Okay. Try this again. Nope. Have we lost horizontal? Oh, it did this once before, too. Cool. I'm not sure which power wire you mean. Okay, well, we had horizontal there, so that's nice. I mean, this is an option. I have only ever used this power cable with it. So I could try a different one. I've only used that one intentionally, though, because it's right angle. To catch everyone else up to the same point that Philip and I are at, we're seeing the 45 volt or 40 volt AC power that comes directly from the transformer sag, which is weird. Every time you have to cycle the AC switch, does that make it work again immediately? I mean, working in that it doesn't show video. Actually, it drops the voltage and then immediately starts rastering again. So you'll notice we'll see the raster collapse, and then I'll turn it off and the raster will collapse again. As soon as the voltage drops, it starts working again. All right, I'm going to plug this in to my electronics bench with a different power cable and no power strip. So it's just going to turn on immediately. So same results. Yeah, so you saw it collapse. I'm now going to unplug it. It goes again because it comes back immediately. Well, we can try and measure the power switch. Checked if the brightness pot is okay. I have not directly measured it. Old Master, apparently we rewire this nonsense. Oh, wait. Under the fuse holder, there's a PCB that you pull out, flip over, and then push back in. So 5 ohms across that. 5 ohms across that. Let me grab something. There we go, 5 ohms. Okay. I don't know what that is, but that's not meant to be a switch. Let's try from there to there. There we go. So I'm going to guess that's 5 ohms across the transformer. Okay. So 0.9. That side seems okay. It's easier. I hate having the beep on, but it's hard to tell if it's the clips or not. So I'm trying to really make sure. Unfortunately, I don't think I can get in there and deoxide the switch. A ceramic ball? Or a ceramic... Where did I read ball? No, it does not. I'm not getting it to have the issue again. There you go, Helen Croft. I got it to do the opposite. It's beep on open now. And the clip popped off. All right. Now we'll just measure the pot. So 85, 3, 146. That's 150K. That's a weird one. Don't think I've ever seen a 150K pot. Okay. Yeah, that looks fine there. So, all right. Gonna plug it in again, see what it does. See if cycling the power switch a bunch of times may have helped. Yeah, I can check all of those. There's so many things to look at on this thing. Jeez. All right. I'm doing this scientifically first, though. Okay. 0.28. 0.25. 0.35. 0.2. 0.27. 0.31. I know what you're saying, old master. I want to see if I can force an issue, though. Not saying I'm not going to do any wiggling and deoxiding. I'm saying I want to do this first to see if I can just find an obvious smoking gun. I didn't accidentally get these right? Wait a minute, this is worthless. Never mind, let's just do it. Yeah, no, this is worthless because these connect here. See. All right. Yeah, let's do it. Oh no, are these the locking kind? This is awful. Hold on. I want my daily carry pliers for this. They're optimal.
Belgiumet says birds do it, bees do it, even educated please do it dash let's do it. Let's wiggle these spade connect ORS around a bit and see what happens. CHEER 100. End of line.
Ben, thank you for the 100 bits. Oh, they're not coming off with my fingers because they're sharp. I'm not cutting up my fingers on these things. The plastic was not very good as far as the injection molding. These are DC caps. They're probably not touching that. Okay. Oh, wow, that one was very tough. If we don't fix this today, the very first thing I'm doing tomorrow is replacing that dual element capacitor. Can't get this one off. I'm just going to hope it's good enough. Oh my gosh, there's so many going down this side. Yeah, we wasted a whole day on this, Ben. Again. Ugh. What's wrong with never-ending content? This content sucks. There's a reason I'm not recording right now. Ah. Two more. I wonder if I should consider myself lucky this thing's not popping breakers. Okay. That is every transformer connection. Pull the fuse off CRT power supply, watch the composite, and dial the brightness. The brightness doesn't impact composite video. And without the 70 volts going into the CRT circuitry, it will do nothing. Kilowatt's really slow. I don't think it would catch anything. I've been running it through the kilowatt the whole time. I don't think it min-maxes, does it? Yeah, I don't think there is a max on there. Okay. Oh, there's this fuse holder too, by the way. Isn't that fun? Like, look at this one. I think it's a fuse. What does this go to? The switch? Yeah, hey, look. Is that just an aluminum bar? You ever just want to scream? Like really, really loud? What else do you think I'm putting in there? I don't have a rating for that. Additionally, there's already a fuse here and a fuse here. So there's a fuse on the AC side and there's a fuse on the DC side for the CRT. This controls all power going into it. So the fuse here is effectively equivalent. I don't know why that exists. It even has an official part number. Jeez. Can we screw the ground terminal in CRT? Sure. Just because you asked nicely, and that you asked it all. And I've been putting it off. Technically, it's supposed to go down there, but I'm at the point now where just like, whatever. I don't care anymore. I think somehow I lost a screw. Okay, everything looks good. Power pulled out. I hear raster. No blinking cursor. And there's collapse. Well, Philip, I just cleaned the connector slug.
X step is going upside for a loud scream. End of
Yeah,
line.
no kidding. Thank you for the 100 bits, Chloe. I got a dumb thought. What's this look like? I hear raster. There won't be a character. We're not going to see anything. But if I turn it up, it collapse like this. Yes. Okay. We're henceforth debugging with no cards. By the way, these cards are exactly Micronova sized. I found that out today. Oh, this did not work as well because I didn't have a good flat surface, but whatever. Close enough. Yeah, it's not going to do video in just because we removed the boards. The actual CRT takes horizontal, vertical, sync, and video in. When you measured the pot, you turned it clockwise about 55 measurement, it dipped. I can double. Well, are you sure that it dipped, or was the meter changing the range? Because that's another thing. Is the meter will change the range, and that can look a little weird. No, the aluminum slug seems to have not fixed it. I haven't tried to measure resistance across that. And yeah, we can do the range test again. It's not power supply. At least, maybe, it's not power supply. Because the problem... Actually, hold on. Range. Manual range. We're measuring the AC power as having issues. Oh, whoa. Hold on, let me get the clips on. Man, that seems pretty good. The only way I could do a more... You know, I'm not even going to say it, because I just don't want people suggesting it. Okay. Main transformer, the monitor AC ended up shorted or similar. Can that cause a mess on the others too? Yeah, that's what I'm thinking maybe happening with the DC stuff. Going wonky. This is the other side of the windings. Yeah, it looks really good. Yeah, it feels fine. I want to measure the 70 volts again. Come on. Okay. No, okay. I wanted to see if it dropped. It does not. It's just instant. Why would it instantly cut out? Oh, Ben, that's the most important thing. You gotta go do that. I was really expecting the voltage to sag. If it was over current, wouldn't it sag first? No, it doesn't have to be a speed thing. I should have been able to control that. Which resistor in the CRT power board looks a bit toasty, the big one. Of course, why would I have taken a picture of that board? That would have made sense. Oh, here we go. 159. See, it's brown all around that area. There's a Zener, but it is not, well, I don't know about in the brightness circuit. Checking the transistors is hard. Especially checking the primary one that does the regulation. The main regulation op-amp transistor thing is right there. That is right behind the CRT, way down in there. It is not possible to remove it without removing the tube. So I don't really want to try that. I want a curve tracer for that. Yeah. Yeah, the connector goes right here. That part's easy.
Spyro the Protosubbed as Tier 1 and says, end of line.
CRT Wrestle just work tomorrow. It will. That's the thing. It will. It'll work up until I get to that brightness level after I let it rest overnight. I guarantee it. That's the frustrating thing. And Spyro the Proto, thank you for the tier 1 sub and for 36. That's 34. 36 is, 36 months. I appreciate that. That resistor on yours is not hot. Well, that's curious. Yeah, it's the Zener that's in this mess, and I don't want to get into that. We're definitely not getting into that in 6 minutes. Poot, all of the everything is under the flyback board. If it's not on this, then it's under the flyback board. On the power board. It's not, yeah, what you're saying is the 159 is not hot, you're saying. On yours. We can pull that off and check it, the resistance on it, just for kicks. Do we solve anything? Just world hunger. We didn't fix this, so it's a fail. I don't know that it's actually that resistor that's getting hot. It could be this chip. I feel like these two resistors are probably getting hot based on the way that the PCB looks, though. That's my suspicion. So does your board like that not? Does this board on yours not look like that? Also, you have that cap, right? And yours is fine, or did you replace it? So 5.6K for the roasty resistor. Not toasty. Okay. And 10K for the other. There's the schematic. Let's see. There's 159. 159 should be 2.2K. Oh, that's worth a leg lift. Helencroft, get ready to screenshot. So that one, according to the schematic, should be 2.2K. I'm never going to learn how to read color codes. So, you know, there you go. Fifth 5.6K. Okay, so that is correct then. So why does it not match the schematic? So BK, we can't adjust the brightness without that because the 70-volt power supply powers everything in the CRT. Oh, what do you know? There's one at 1, 2. Who would have guessed? Okay. So it's 156 that's getting really hot. The schematic says that's an 8.2. Yeah, it's 156. I'm just stupid. The number was upside down. But still, the schematic calls that 8.2. But you guys are saying that's the correct stripe reading. I do not have a 70-volt capable power supply. I mean, technically, I could run my 2 DC power supplies in series and get 70 volts out of it. Oh, I'm not gonna change this based on the schematic. Yeah, we're definitely not doing anything in a minute. I'm stalling until 2 so that I can end. I might be able to peel the glue out. I don't know. All right, well, tomorrow we're replacing that and seeing what happens. So, yep. That is the final electrolytic in there as far as I know. Yeah. Oh my gosh, that's super pretty. There's an inductor in there that's in the shape of a resistor and it's got the coils wrapped around it. And then they put resistor stripe codes on top of the coil, so it's a painted inductor. Looks kind of cool. Alrighty. I need to remote into my server. So Peter, it fully rasters. It's doing full raster. What happens is the raster collapses when the brightness goes up. So it's not full short. Something is going rogue at some point. I don't know, man. Yeah, all right. Tomorrow we'll swap this cap. Oh, hold on. Let me hit the outro button. All right. Okay. What do you mean it might actually be 72 volts? The problem might be the 72 volts. Well, you know where I am on Discord. All right, tomorrow we're gonna replace this cap because I don't trust it for nothing. At the very least, we're gonna remove it and measure stuff. It's gonna suck. I'm gonna have to heat the board, which means we get to use a thing. I got a PCB clamp. We're gonna put the clamps to it. Click, click. So yeah, we'll use this, heat the board from one side while I simultaneously try to remove it. Oh, it's almost like this is the size of the board that they expect to use with this thing. So yeah, we'll take a look at this tomorrow. Whee! Woo! Wait, it's spring-loaded? That's weird. All right. Anyway, yep. That's it. Okay. This is not going to be a trivial repair, it seems. Yay. I'm still expecting it to be something stupid, though, when we find it. So, all right. Anywho, that's going to be it for today. I will see you all tomorrow when we continue working on this nightmare that I thought was not going to be something I was working on yet. So yeah, if you enjoyed this stream, then you are cruel. No, I'm just kidding. If you enjoyed this stream, you may want to follow to be notified when I go live again next. If you want to help support the channel, you can find me on Patreon or get a shirt like this one. But that's going to be it for now. So, I don't know. I say words at this point. I'll see you next time. Bye.